Hello friends, my name is Pranav Deshmukh. I am studying in B.Sc second year and today I am going to tell you the theorem which is known as operation on divergent sequence. Before going into the theorem, we have to know the basic concept sequence. So, in mathematics, a sequence is an enumerated collection of objects in which repetitions are allowed and order matters. Like a set, it contains members. The number of elements is called the length of sequence. Unlike a set, the same elements can appear multiple times at different positions in a sequence. Unlike a set, the order does matter. So, the statement of this theorem is if sequence Sn where n is equals to 1 to infinity and sequence Tn where n is equals to 1 to infinity are sequence of real number that diverges to infinity, then so do their sum and product, that is sequence Sn plus Tn where n is equals to 1 to infinity and sequence Sn into Tn where n is equals to 1 to infinity diverges to infinity. So the proof of theorem is, so let sequence Sn where n is equals to 1 to infinity and sequence Tn where n is equals to 1 to infinity be two sequences of real number which diverges to infinity. That is, limit of Sn tends to infinity where n tends to infinity and limit of Tn tends to infinity where n tends to infinity. Then, by definition, for any positive number capital M, there exists a positive integer n1 such that Sn is greater than M for all small n is greater than or equal to capital N. So this is our equation number 1. For capital N, there exists a positive integer such that Tn is greater than 1 for all small n is greater than or equal to capital N2. So this is our equation number 2. So let n is equals to maximum of n1 comma n2. Therefore, both inequalities hold for small n is greater than or equal to capital N. Then Sn plus Tn is greater than m plus 1 for all small n greater than or equal to n, so that Sn plus Tn is greater than capital M for all small n greater than or equal to capital M. Hence, limit of Sn plus Tn tends to infinity where n tends to infinity is proved. Also, Sn into Tn greater than m plus 1 for all n is greater than or equal to capital N, so that Sn into Tn is greater than capital N for all small n is greater than or equal to capital N. Hence, limit of Sn into Tn tends to infinity where n tends to infinity is proved. So that there are two remarks. If sequence Sn is a divergent sequence and it diverges to infinity, then sequence minus Sn where n is equals to 1 to infinity also divergent and diverges to minus infinity. Also, the product of divergent sequence minus 1 raised to n where n is equals to 1 to infinity with itself is not divergent. Thank you so much for watching this video.